Alright, question 13. I've only got a badly one that came out in the wrong places, so I'm going to use this. Anyway, we know the speed's 56, we know the mass is 8,300 kgs, horizontal track A, and it becomes stationary at C. Let's take a look at what this is all about. So it's going fast there. I believe at A it's doing 56 meters per second. I'm going to put this here, 56 ms to the -1. At C, the highest point of the track, and it becomes stationary at C. There we go, 0 ms to the -1. Okay, what's it asking us for? Well, first question, the angle of the track at B is 25 degrees to the horizontal. There we go, they've even put in the angle for us. That's nice. Calculate the component of the weight of the car and the passengers acting along the slope. Well, there's no component of the weight acting up the slope. That's the first thing to recognise, because, well, weight doesn't act upwards, it acts downwards. So let's put in a little weight vector and let's think this through. I'm going to break this off into two values. One that is perpendicular to the slope, like that, and one that is acting along the slope, like that. And we want to know what this is. So this is going to be W straight down. We want to know what this is. Well, if that's 25, that angle there, this is going to be, you can clearly see that's the smaller angle, 25. So this is going to be W cos 25, and this one's going to be W sine 25. Or you could put cos of 26, 25. Or you could put cos of 65, whatever you want to. But it's this that we're interested in here, the component that's acting along the slope. So what is the component? It's only a 2-mark question, it's not going to be too tricky. Comp equals W sine 25. What's the weight? Well, we know the mass. We know the mass is 8300, and I believe we're on Earth, so 8300 times by 9.81, whoops, brackets, times by sine 25. Get your calculator. 8300 times 9.81 times sine 25 equals, whoa mama, there it is, 34410.8. So 3440 newtons. Okay, that's the component. B, calculate the kinetic energy of the car, including the passengers, when travelling at 56 meters per second. I genuinely can't believe that you get 2 marks at A level for this. I'm pretty sure you wouldn't get 2 marks for this at GCSE. But anyway, there you go. This just proves that if you even can pick up a pen, you can get something in an A level physics exam. So half mv squared times by 8300 times by 56 squared. Let's do that. 56 squared times by 8300 times by 0.5 equals 1301440. So let's do that to 3 sig figs. In fact, let's put that in standard form, shall we? 1, 2, 3, 4, 5, 6, 7. 1.30 times 10 to the 7 joules. Beautiful. Alright, calculate the maximum height above A that would be reached by the car and passengers if all the kinetic energy could be transferred to gravitational potential energy. Righty-ho. Maximum height, 2 marks. So we know it's 2 marks, we know it can't be too tricky. So we are going to say half mv squared is going to be converted to GP, GPE, sorry, excuse me, mgh. Half mv squared equals mgh. We can get rid of the m's there on both sides, that doesn't matter. We just want to find h. So we can say a half v squared times divided by g. It's going to give us the height. Okay? Or rather, to write that properly, I should really write v squared over 2g. That's going to be the height. Right then. 56 squared divided by 2 times 9.81 close brackets gives me 159.8, which is basically 159.8, which is going to be equal to 160 meters. Boom, easy peasy. 160 meters. Alright, the car does not reach the height calculated in part B. Explain the main reason why the car does not reach this height. Okay, we know there's going to be frictional forces, resistive forces. Okay, I'm going to tell you what the key word here is. Resistive forces. That's our key word. We should name them, okay, that's what we really want. Friction, drag, air resistance, whatever you want to call it. We're named forces, that's the first mark, okay? And therefore, if we are we're going to do work. Work is done overcoming them. Work done is force times distance. So, work is done against them, e.g. energy is converted to other forms as opposed to just gravitational potential energy. And the other forms, okay, the other forms will be heat. That's what we're looking for really. Thermal energy is the word you should use, not heat. Thermal energy. Okie dokie. The car reaches a point C, which is the height of 140 meters above A. Okay, now theoretically it had a maximum potential height of reaching 160. It's going to get to C, which is 140 meters above A. Calculate the speed that the car would reach when it descends from rest at C to its original height from the ground at D if 87% of its kinetic energy, of its energy at C is converted to kinetic energy. So this is basically where we're going to a situation where the MGH is not going to be 100% converted to half mv squared. But what we can say is that 0.85% of this is going to be converted to that. So this is an MGH 87%, which is times by 0.87 is going to be equal to a half mv squared. Now, we're away and laughing again. We've got m on both sides, that's all good. We've got g times h times by 0.87 is it times by 2 square rooted. That's going to give me my velocity. So I want to do gravity 9.81 times by my height, which is 140, times by the fact that it's not going to be all converted, which is 0.87, times by 2 to get rid of the half over there, and then square rooted. That's going to give me my velocity, and that's going to come out to whatever it comes out to, 9.81 times 140 times 0.87 times 2 equals, oops, hang on, that seems too big, square root the answer, 48.88, which is basically 49 meters per second. Simple as that. Okie dokie. Now, a lot of people on this thought that what you could do is just get the calculate the velocity and then multiply that by 0.87, and you can't do that because this velocity squared is kinetic energy. Anyway, that's the end of that video. I've got a phone call to take.